Hi, and welcome to this presentation. I will walk you now through this presentation so it helps you to prepare your own. You have the Prezi file, and so these are some ideas what you can say with the words and pictures I provide. I usually use this presentation alongside the various aspects of ATLAS.ti I explained, so it is used over a 2-day course if I have a 2 days training, or if you use it in seminars you can actually spread it throughout a number of lectures, so it's not really meant to be shown in one go. It takes probably about an hour and a half if you go through it in one go. So take it step by step and alongside what you explain on the technical level and the mouse clicks in ATLAS.ti. So you can start with telling your audience that you would like to take them on a journey of computer-assisted analysis with ATLAS.ti. And before you go on a journey, well, what you usually do is you get ready, you get prepared. And getting ready in a computer-assisted analysis means thinking about proper data file names, where to store them on your computer or on an external drive, what I want to do in terms of backups and transfer of projects. If you prepare that in advance, it will help you and save lots of times in the end. So your first consideration should be about data file names and how to set up your project. You see here some prefixes so to organize your data files even before they are assigned to an ATLAS.ti project. And so this setup actually refers to version 6. There will be changes coming in version 7 of ATLAS.ti that makes things a bit easier. But nonetheless, good data file names will stay a good rule. So the G stands for German, US for US newspapers, L for local, N for national, BS for broadsheet, paper, and so on. So what we see here is one project folder, and that project folder contains the ATLAS.hu file. And the second alternative is, if you have lots of data files, to organize them into subfolders and then store the ATLAS.hu file on the top level in the main project folder. What's important, and I suppose you have explained that before in ATLAS when you did hands-on setting up a project, that you don't make changes after the project is set up. You can do so, but it's always involves like how to do this and what to do, and it's some extra time and labor involved, so it's best to think that through from the very beginning so you don't have to make changes afterwards. So once that's sorted out, so after these first steps of setting up the project, we can take a look at the data. And here I like to work with this metaphor of landscape. Our qualitative data, or you can think of them like exploring a new data landscape, like the ethnographer and anthropologist is going to a new culture, a new country, a new village that he or she explores. Well, here we also have in front of us a valley with a number of things on it that we can take a kind of a quick look at, and but our task is now to explore this more deeply and see what it has to say to us. And this image of this data landscape and this valley will accompany us throughout the entire journey until the full story unfolds. These days we are used to have a navigation system if we are in some unknown territory, and our navigation system is the NCT-model. And NCT stands for noticing, collecting, and thinking. Noticing means if we read the data, look or listen, look at or listen to the data, then we start noticing things, interesting things that we may take some notes about, that we mark on on paper if you read a paper, and now we do it electronically. So after we read through the data and we find things that occur again and again that seems interesting to us, then we start collecting those things. And collecting in this context means coding. So we will return to this importance also of collecting a number of times. So you start noticing something, and of course you think about the things you notice. Once you see some commonalities occurring again and again, you start collecting and applying some first codes. The thinking part will become more and more important in the later stages of the analysis, when it's about memo writing and thinking through what we have been coding. And so this process of noticing, collecting and thinking about will be our companion all along, helping us exploring the data landscape. And you see, and remember that a bit later we have some very thick arrows here in the middle, pointing that it goes back and forth between these three elements, and some small WASGIJ type arrows pointing that, well, it's not necessarily sequential. We will return to that a bit later. We all have played a puzzle, I suppose, one time in our life, maybe as children, maybe also as adults. Thinking about playing a puzzle helps us to think about coding and how we may want to approach coding. And looking at something that's familiar to us makes it easier than to take on a new task if you haven't done coding so far. So if we have a puzzle, and let's assume now we have a puzzle of 1,000 pieces, these are not that many that you see on the screen, and they're all laid out in front of us on a table. So you can do this part of the presentation more interactively and asking now people. So now we have all these pieces of the puzzle on our table. We turned all of these pieces around. So what are you doing now if you play a puzzle? How do you start? And you will get two answers. One is to start with the corners, and the other is sorting by color. So we need both of these strategies. Let's start with the corners. And this is actually images of an online puzzle. So there is an option where you can just click and all the middle pieces disappear, and you only have the corner pieces that you can start sorting. So why people like to start with the corners and edges, because it's easy. Because it's easy to see. It's at least at on one side it's a straight line, and the corners are rectangular if you happen to have a rectangular puzzle. And that's why people often like to start with the edges and the corners. And I say, well, let's start with that in qualitative data analysis as well. Let's start with those things that are easy. Those things that we already know about our data. These are our sample criteria, if we had any. And most of the time people look specifically at certain groups of people based on certain criteria. So that's something we have seen in the data file name, for example. There's a comparison between German and American newspaper. So that's already a piece of information that can go into the file name that facilitates analysis later on in ATLAS.ti. The data file names, it's not a must, it's a nice to have, and you will see it if you do it. That is actually quite helpful also within the software itself. So the corner pieces in the puzzle are like framing our study. On a technical level, creating the project folder and naming the data files, sorting them maybe into subfolders, so all information that we already know. And when you're in Atlas, once you have set up your project, well, let's start, for example, with creating document families, because that's easy. at least if it's in terms of variables like gender, creating a family for males and females and age groups and profession, and so on. So that's also like framing your study in a way, starting with something that is already known. You can create families at all times in your analysis, and maybe later you have some families that are based on content, on types in your data that you don't know from the very beginning. But it's a nice kind of getting started with your project, starting organizing your data and framing your project. Well, then we still have these 800 something pieces of the puzzle, if we have 1,000 pieces, that we need to do something about next. So what do we do then? So you can ask your audience again what they suggest. Well, they suggest probably sorting by colors or themes that you have seen on the cover of the puzzle. That can lead to a question, so do we have something like a cover of the puzzle in our research projects? If so, what is that? People will answer your theory, your research questions, your interview guideline, things like that. Some may say, well, I don't have a cover. So depending on how inductive, deductive, how much hypothesis-driven people's projects are. So, but you can make them think along those lines, whether they do have something similar, like a cover page. If we have an interview guideline, some certain themes we want to look at, so that's also like looking for certain aspects in your puzzle. Like here, we have the castle, some forest, pieces of forest and lake that we can start to sort. So that means now collecting those pieces that are similar. So we notice certain themes in the data and we start collecting them and putting them all together. Let's stay with the castle image now. So we have put all these pieces together that looks like a castle. So what's next? Yeah, then we now try fit the pieces together. Again, we can be systematic about it and look for what actually belongs together. Yeah, those top pieces here of these towers, then the balcony, and we've seen this tree here, so we look for the puzzle pieces that to get this together. The roof, and so the windows and stuff. All this give us points of where we can connect things. That's actually the point where we have collected everything in a very large code group, where we develop subcategories. So you see this puzzle analogy is a bit one-sided. It's only kind of the top-down way. We collect everything on lots of elements on a big theme, and then we subdivide. We will see later on that it's actually also normal, that it goes both ways, that we sometimes collect smaller and name smaller pieces, and then we need to aggregate. So once we have done this, we fit everything together, all these various pieces that we have found in our puzzle, so the whole picture comes together. Here the analogy stops, because in our projects we usually then also look at how things relate to each other and how they fit to each other, and that brings us to the analysis, function query tool, co-occurrence explorer, and so on, and then to visualize these things we found that are related, to visualize them in the network view function. But of course we don't put together the image that was there before, like in a puzzle. But that's a normal puzzle. There's something like it's called a WASGIJ, or however you want to pronounce this puzzle. If you look at it backwards, then it's jigsaw. So the jigsaw puzzle is actually a puzzle where you do get a picture, like this one. But if you place a puzzle, it's not going to be the picture that you end up with. It might be from the perspective of this person here in the car, the perspective of the policeman, the perspective of these poor people here lying on the tracks, or the train driver. We don't know. We found out while we play the puzzle from which perspective it should be laid and how it fits all together. And I think that's a nice analogy with what we're doing. We have a perspective, ours. The theory brings a perspective to the data, but what we want to put together is a perspective of our respondents, of the people we study. So that's why I feel like, or think like, these WASGIJ puzzles are a nice analogy of what qualitative researchers actually are doing. So if you now transfer this model to computer-assisted qualitative data analysis, then it may look like that. Now, on the technical part, we think about things like project setup, data file formats. Do you want doc files, rich text files, PDF files? If you work with video files, what are the best formats with image files? What is the good size, and all that kind of things. All these technical bits have to be considered. We can't just get started and download the software and assign some data, and then we sure get into trouble later on. So do think about this part very carefully. So once this is done, project is set up, nicely sorted and ordered. You start reading, looking at your data, start noticing things. And then you find all kinds of bits and pieces, those things that are similar here, shown in terms of squares and colors and circles and so on. So that means coding your data. Then use the software to sort and structure, building your coding system. So it's all the collecting bit. And then once the data is coded, you have a good means to, or better means to think about your data. Of course, you do some thinking all along the time, but now we can query the data, use the analysis tools, and then hopefully discover nice, interesting things in our data. So this looks easy now, noticing, collecting, thinking, done. Well, remember the big files in the middle, arrows in the middle, and the very thin ones along the side. So it's not always sequential. That's more like how your daily work as a qualitative researcher looks like. So don't get frustrated. Just remind yourself you're not the only one that goes back and forth and reworks the coding system 2 or 3 times. Maybe after thinking that something has been discovered, well, go and collect some new data, rereading stuff, recoding. So it's a lot of back and forth until you're happy with your coding system, until you're ready to query your data. So don't get frustrated, it's just normal. But, well, the report needs to be written at some point. Your thesis is due, you have the conference paper, if you have a research project, then you have to submit some reports at some point. So we do have deadlines. And this is where the memo function comes in, quite useful. So I have some suggestions how to can build up your analysis in a systematic way, so you actually also reach ends, and in terms of in time. So don't spend months and months and months of coding. Well, there's some time involved in doing that. But you have to get writing. Writing is very important, and also a very important part of the analysis. So we'll talk about that when I talk about memos. So with this introduction, you can set people on to begin the journey. And that means taking a look at the data. You can use my example data, you can use some data you have brought with you, or maybe students have collected their own data. So now it's time to begin reading, noticing, and collecting. Theory, interview guidelines, first kind of ideas, sorts can of course guide you in this process. What I'd like to motivate people is to stay open, to have lots of ideas, lots of sorts, and actually, well, I'm not a very good painter or drawer, but this kind of reminded me of my visit at Yellowstone Park, where we had all the bubbling type waters and these smoke of hot temperatures coming out of the earth. So there are the sparkling ideas and the bubbling salts are coming from. So go and read and have lots of ideas and start coding once you feel that something comes up again and again. Don't think too much about structuring, at least not yet. If you do that too early, I always say, like, how do you know after 5 minutes what's a sub or higher order category? Yeah, Atlas doesn't have a tree structure, and in that sense it hopefully facilitates this open way of coding your data. You will see later on how you can structure your coding system, and once you know how to do that, well, if you have a more deductive study, then you may set it up like that from the start. But if you want to work inductively or a mix of inductive, deductive, have lots of ideas and thoughts now. So with that image, let people go and do some coding work. If it's in a workshop setting, 40-45 minutes until you see their first interest is gone. If it's only example data, it's not their own data, or if they start beginning to have more questions like, oh, what do we do with that now? And then you can ask about the kind of codes they have generated. So this is like just naming what's in the data landscape. Yeah, there's some forest, there's some trees, there's some flowers, there's a house, there's some people, there's a boat, there's some mountains. So not very in-depth description, it's just saying, well, these are things that are in the data. In terms of codes, it may look like the following list I'm going to show, and I'm now borrowing here a term from Johnny Saldana, first cycle coding, which I felt like fits very nicely. And these 4 lists are actually from 4 coders coding the Schwarzenegger data, actually I think from 4 different workshops. But you may get that in a group of people, that some people have lots of codes, and if we take a close look at the code labels in a moment, they probably code much close to data. The fewer codes I have, maybe they are slow readers, but oftentimes the codes are more abstract. So, and they have collected more things under these more abstract code names. If you look at this very long list, we have words like Maria Shriver. It's just the name of Schwarzenegger's wife. Well, a 5-point plan is just an in vivo code coming out of the data. Gray Davis is his opponent, Hollywood star, financial gap. These are words from the text, so coded very close to the text, and therefore the list of codes is very long. And that person here on the other end of the scale, well, he has codes like economical framework, description of person. Instead of just Hollywood star, it's more on the abstract level. It just combines everything that's about the person. Policy framework. So you can collect lots of things under the term policy framework. So wherever you are, you will figure out after your first coding experience. And I like to compare this with the normal distribution. Most things in life are normally distributed. So we do have people with lots of codes fairly early on. After 2-3 interviews, they may have 600 codes, and some only have 50 or 60 codes. So they're at these very extreme ends of our normal distribution, and most people will be in the middle. Yeah, having some abstract codes and having codes very close to the data. So most of the times we have to do both. We have to subdivide large groups of codes, or we have to aggregate codes that are too close to the data, because it doesn't make sense to end up with 2,000-3,000 or even more codes. You just kind of feel like running into a wall, and you probably end up leaving Atlas and doing things by hand again, because you don't know what to do and how to do it. And that's why I'm now explaining what to do in either of the two situations. So what you need to do now after this first coding, and that means code as long as you have no further ideas. That may mean 2, 3, 4 interviews. If you have shorter newspaper articles, you may need 20 short articles. If you have a blog, depending how long the blog is, maybe one blog with lots of posts will already be enough. As soon as you feel like things are repeating, codes come up again and again, and you do use drag and drop coding a lot, then it's a time to take a break and review your codes and now begin to sort in structure in the next step. So I already explained the two situations. You may have a code that collects lots of things. Now we have to subdivide. And we look at this example now of the code political program, which has been coded here 21 times. Always remember this is a small just example project. So what you need to do, of course, is to read through the data, through the 21 codes, and you can write a memo on your kind of thoughts of what kind of content it's within it. You can write it on a piece of paper. We can start kind of counting how often a certain aspect occurs. So these give you some ideas what might be a viable subcategory. So these first notes may not be your subcategories yet, but these are things that you do the whole process of noticing, collecting again, now within a smaller area of your data. And by just focusing on one topic, it's much easier now. Yeah, so if you don't have ideas or not sure about subcategories, why you go through the data first, or your first 2-3 interviews, well, just collect them in one code. And then after you have collected 20 statements, it becomes much easier when you review them to think about proper subcategories. And then you do some noticing again, you collect those things within that category that are similar again, and then you create your subcodes. So they first will be empty, so you see that as here in the numbers. And now you have to via drag and drop, so you have to explain the technical side of that, and to distribute it, the codes or the quotations from this now category name into the subcodes. And then you start seeing how I start structuring the list with prefixes. You sometimes have to trick the alphabet a bit. That's why we have P_political program. So the name of the category is actually on top of all the other codes. And as a habit from version 5, I do write it in capital letters. We didn't have colors in version 5 for codes, but I still like it as kind of a nice marker where a new category begins. So then you distributed the quotations into the subcategories. So the aim should be that the top or the category name is empty, so no quotations linked to that anymore, and all the data is now contained within the subcategories. You can now use the main category label for further collecting. So if you continue read the data and code the data, there may be stuff that already falls into the subcategories, but other stuff you don't know yet. You don't have a subcategory for yet, or you don't know where it fits. So collect them here again in the main category and think about them later. So these are quite useful, even they may be empty in the end, or still have one or two, or you have a subcategory miscellaneous if they don't fit anywhere else. But that's the purpose of here, like indicating a new category, but also quite useful in the process of coding. So let's look in the other way around. If you code very close to the data, so these are not codes yet, these are more descriptive labels. They are called codes in the software because the software only has one name for it, but think of them as descriptive labels, and now we have to move them or turn them into something what I call methodological codes. And the examples that we're going to use here are some codes about the various ways Arnold Schwarzenegger has been named. And if we code very close to the data, then we are in the danger of walking into the code swamp. So if you realize that you very fast have lots and lots of codes, like I mentioned, 500-600 codes after coding just 2 or 3 interviews, well then think about this little guy with a red flag that should kind of come up in front of your inner eyes and reminding you, say, well, there was something about the swamp. We don't want to go in a swamp. A swamp is dangerous and it's difficult to get out. So if you realize you are the kind of coder or for a particular project you are like that, well, you need to do something about it. We don't want to end up in the code swamp. The technical way of doing it is via the merge functions. The way you can recognize it in your coding system if you have lots of codes with very low frequencies. Yeah, so check the frequencies here at the end of the code. So this is the single column view. That's kind of all you need when you code and not the detailed view. And so it's easy to spot all the codes with low frequencies. So here we have codes that refer to as professional biography, bodybuilder, Hollywood star, an actor, the megastar, and so on. Where this is actually based on his political career. Husband of a television journalist would be related to his personal life, and 50-60-year-old is also more in personal characteristics. So if you go through all of these terms, you easily can see that, or easily hopefully think about more abstract terms like the professional biography, or a personal biography, or the biography of him as a politician, talking about Schwarzenegger. So you can merge these now into more abstract codes, and that might be how it looks in the end. So we may have these biographical codes, the stuff on his political orientation, things attributed by others, particularly by voters, and for now we have something on him as being a political novelist. It may actually turn out to be something else in the end, or end up in a new category. But it's kind of steps in between, and we have now collected quotations under more abstract labels, and it becomes better to work with and also to keep an overview of our project. And that's actually a second way of ending up in the coding swamp, and that is if you, especially on the dimensional level, if you think in terms of dimension, that you end up with too many codes. What you see here is that we have an evaluation of each person or each event in positive, negative, and neutral, and all attached to the end of the code name. So if you have something like that, or if you realize you start multiplying codes, especially in terms of names, especially at the end of the code label, then that's a different category. Yeah, so here, take it out. This is category evaluation with the different properties here again, or dimensions, and we have a person category. We may have an attitude category, we may have an event category, an emotion category, whatever. So keep those things that I don't lump too many things into one code label. So if it's a different layer of code, then keep it separate in different codes. And that's because we have software. Because now, if we code like that, so we have one coded segment here, but we have two codes attached, the person David's and a neutral evaluation. And we may have a third aspect, if there's a third aspect within it. We have the co-occurrence explorer. To find all co-occurrences, we can use a query tool to look for all neutral descriptions of the person David as compared to neutral description of Schwarzenegger, and so on. So this gives an easy means to query the data, and also to get a good overview also in terms of frequencies via the table view of the co-occurrence explorer. So this offers different better ways of analyzing your data instead of lumping all into one code label. So also if you see you doing that, the red flag should appear, and you should do something about that. So once you went through all your data, you should end up with a more structured code list, and an example could look like that. You can then start also setting colors. You easily spot the start of a new category with the capital letters, and you see I've used these prefixes all the way through. So that could be an example, or it's an example of how a structured and sorted code list looks like. If you want, you can also use numbers, but be careful. Don't have like numbers like 1, 1, 1, 1, 1, and don't overdo it here. Numbers are sometimes useful if you don't like, or if you data don't fit on kind of the alphabet. This is about merger acquisition process. So normally what's important here is to look at organizational fit. Well, alphabetically this starts with an O, and the final results start, it's F, or emotional results, it's E. So alphabetically the results section would actually end up quite high in the list, and the organizational fit would be at the very bottom of your code list. By adding some numbers, you can kind of force the category order in a more logical, content-based way. What you see here is, in addition to the numbers, are some letters to indicate the main kind of a category idea, like here is justice or here is controllability. That's especially for third persons. If you are the person doing it, then, well, the numbers make sense to you, but for others it doesn't make so much sense. What's your code 212A or 347C or whatever? So think about transparency of other people to be able to understand what you're doing, and that's not personal code list for yourself. So these can actually help adding some transparency to it. So after this restructuring, resorting of your data, the data landscape looks already a bit better explained. And now it's not only the forest, but we see, well, there are actually stems, there are top parts of the tree, there are bushes, there are different types of flowers, there are red flowers, there are blue flowers. So we have been looking at our data a bit closer and now describing it in a bit more detail and getting a bit closer to understanding what's going on in our data landscape. So once at this point, you can now take your code list and continue to code the rest of your data. There will probably be still some changes. There will be maybe also new categories, new subcategories. You may still shift things around while you code new data. So the process is not yet finished, but at least you can you have something now you can work with in a more systematic way, and it's easier to have 12, 15 categories instead of 150 unsorted codes. So it's not also for others to better understand your code list, but also for yourself, if you can just work with in your head with some fewer categories instead of 150 code labels. This way also you have a step of verification whether your code list works already quite well. If you think you have to redo a lot of it, you know it hasn't. It wasn't still that sorted and that structured, or you missed out a few things. So you do have this step of control and verification at this during this process. So at some point, the data is coded. You may already write some memos, comments through this process. What I want to talk about now is about memos, but also about memos in the for writing up your report for the detailed analysis process, and also of course hinting towards the first type of notes you're going to take that may turn into more analytic memos that you can use for your research report. In the data landscape, well, there's lots of benches. There are lots of benches, as it is important to write memos and not spend most of your time coding. As if we're on a journey, we need time to rest, we need time to digest the experience, we need time to think through the experience, to reflect on it. so we're not all overwhelmed of all these new impressions that we get. So take your time to rest, take your time to think, and oftentimes that may not be in front of the computer. Yeah, you may go on a walk, or you may be in the shower, you may talk with a colleague, you may talk with a friend, you may read something interesting in a book, in a journal article, or in a newspaper. And that helps you to think forward and to reflect on your data. You can take notes wherever you are, and we talk about computer-assisted analysis. These have to end up at some point in the computer. And what I want to especially tell you is how you use the memo function in ATLAS, because I often see it used as common function, which I do not recommend, or it's not used at all because people don't know how. So I want to make some suggestion and take whatever you find useful to do. Remember that we have said before that working with 1,000, 2,000, 3,000 codes, like too many little containers, is not a good idea. Codes are containers for your quotations, for your data segments. Memos are containers for your ideas. Don't write 500 ideas and every idea has 1 or 2 sentences. Also, think about what kind of themes you want to write about. So also consider memos as being containers. And that's why people end up using memos. If they have 50 memos and in each memo they have 2 sentences, they kind of say, oh, what is good for? I'm only getting lost. So do keep this container idea in your mind if you write memos. They may start with 1 or 2 sentences, but they should grow into something larger of a few pages or a chapter in your book, or thesis, report, and whatever you write. So to give you some ideas of types of memos, well, if you, in the seminar setting, you may, well, first people give them an assignment, think about a definition, what are memos for them, how would they use them in their research project, what kind of memo they could think of, what kind of memos they have been written in the past. Let them think through that first, because you give them some answers or some ideas. The research diary for all scientific type research work is a good idea, especially if you still want to qualify in the qualification process of writing a thesis or master or PhD thesis. That's very important for reporting on your research later on, so you can remember what you actually did, so you can report on it in terms of transparency and rigor. Don't write a memo for each little idea you have, just collect all of your ideas. Have an idea memo where you collect all ideas of what you want to analyze, for example. Yeah, you may have an idea but you don't have time, so write it down in your idea memo to get back to that later when you have the time to actually do it. You can have a team memo if you work in a team. Write down everything that you want to discuss with your team before you forget it. So still in this, in the sense of the word, to remind you of something, something that you don't want to forget. The code memo, in the way I see it, is if you have read grounding theory, there it's used to develop your code system. Well, in a sense, it does help in the process as well. You can collect again ideas related to your code system. If you're not clear about a definition, if you think, well, this needs to be differentiated, or that could go there or there, you're not quite sure yet. So questions, ideas that concerns your code system can go in a code memo. So you collect it there and you have one place where you can review it and say, well, what were my ideas? And this is now I have some time to work on it and work through your code system and use it that way. The theory memo, in contrast to the analytical memo, of course, if you want to develop theory, your analytical memos could also be called theoretical memos. What I mean here is that you can put bits and pieces of your theory, important definitions, a copy of a model that you're going to use into a memo. And then if you see data that either contradicts or that speaks to that theory, that or thesis, or some other research findings from other papers, you can link the memo to the data segments. So you can collect empirical evidence for that type of theoretical piece of knowledge. So you can create memos like that if you feel that's important or you think it's an interesting idea. Analytical memos I actually kind of then gave a different name. I call them research question memos. You find lots of different ways of defining analytical memos in the literature. So everybody kind of offers their own definition. That's why I rather call them research question memos. And we will take a look at how I think they should be built up in order to serve as your points of departure for your research report. What we're going to see now is an RTF output of such a research question memo. So we're not inside, well, we are inside Atlas, but in the editor of outputting the memo, and that's the option, output memo with quotations. So what a good research question memo should start with is the research question. What do you want to write about in this memo? A lot of times memos don't even have a proper title. So this research question should be in the title in a short form, and then write it properly spelled out inside the memo. The next question you can ask yourself is, so how do I find an answer to this research question? That means that's most likely after coding, because the data has been needs to be coded so you can query it. So the next question is then, how do I find an answer? What do I need to do? If you know the tools, the query tool, core occurrence explorer, code primary document table, maybe just a simple retrieval on a code, well, write it down. It will add an aspect of transparency to your analysis again. So nobody can accuse you of just having a subjective interpretation. Well, your interpretation at some point, in a certain extent, is subjective, but you can actually tell people what you actually did. So this has been a query that can be solved by writing a code family first, setting it as filter, then running the core occurrence tree explorer. That's actually a screenshot of the result, and then follows the interpretation, which is probably a bit longer than normally than this little bit here, but so to fit it all on one page. And if you find interesting quotations that support your claim or your interpretation, then link the memo to these quotations, and in the output they're included at the end. So if you use this and copy and paste it into Word to write the report, then of course you can insert these quotes with a shorter form of the reference inside your interpretation. What you need from the reference here is that's quotation A2, and that's in paragraph 12. So Atlas gives you the reference here, and you take the information that is needed and how you explain it, probably in your methodology section, and how you want to reference your quotes. So that's an example of a research question memo that you can use step by step to build up your research report, to also approach this part of the analysis in a systematic way. So when you write research question memos, well, you also need to know the tools for further exploration. So writing memos and querying your data kind of goes side by side and hand in hand. So what you see next is an overview of the tools. Well, might be simple reports. You may need the query tool, core occurrence tree or table explorer, or frequency output, the code's primary document table. So in a seminar, workshop, all of these tools need to be explained and practiced. How to create reports. This is just a text report of quotations of a code, while there's a number of XML exports that are actually quite interesting as reports, so that might also be an option to look at. The query tool needs a bit of explanation, how to click it. Yeah, basically codes first, then the operator, and that's also the tool how to combine a code query with variables. That's actually the scope button here, and then you can save your query in form of a supercode. So you need to explain this, of course, in the operators as well, and let people practice how to work with the query tool. The co-occurrence table explorer is more or less a cross-tabulation of codes. And you first get frequency outputs, you get a coefficient, if that makes sense. That might only sense with larger data sets, not with 10 with 10 interviews. The coefficient cannot really be used. Use it for if you have survey data, larger amounts of cases, and so on. It's advisable to work with code families here as filters, so you don't produce a table of everything with everything. And you can access the data by clicking on the cells. Also the co-occurrence explorer, but in the tree view, so this gives us you a quick overview of which kind of code, which codes actually do co-occur. If you open the tree, you have access to the data behind it again. And that's an example of a code parameter document table, a little bit formatted in Excel, so you don't get it quite like that directly out of ATLAS.ti. What I often do is work on an aggregate level, so to calculate the sums of documents that belong to a family, and then these aggregate numbers can often be nicely interpreted. And then if you have some interesting numbers here, well, you know that non-specific pledges seems to be quite high in political culture in the Dallas Morning News. Well, then you can go back and look in the content, read through it, and make your sorts, write your memos, and so on. So these tools, they kind of go parallel while writing memos. You think about what you want to write about, you have your research question, what kind of tools do you need, you run your query, you read through the data, look at your data, go back and write your memos. And at that point, it's nice to have two screens, one screen for running the queries, one screen for writing reports. So ATLAS does support the split of the various windows on two screens. So if you have the opportunity, it's nice to do. So this is actually an example of a more complex query in the query tool. So it goes from here, one, next step, second step, outcome, third step. So you can actually run quite complicated queries in ATLAS once the data is coded. What this query actually does is looking for all quotations where direct speech is used, or for all quotations where a direct quote is used from one of the Schwarzenegger films, like The Terminator and so on. And that only in the context of a metaphor, so if it's a metaphoric language that is used in the context of the election campaign. And you find a number of these things in the American newspapers where they use lots of metaphoric language and always in relation to the Hollywood films of Schwarzenegger. So ATLAS can then find all these, filter out all of these segments for you. And this kind of query can be copied and pasted into a memo. So you do have an audit trail, and it looks also a bit mathematics. So if you want to have to convince non-qualitative researchers that we also do systematic analysis, that we do query data also in complex ways, it's all not just reading and writing some stuff about it. That's a nice way of doing it. And hopefully then you reach the summit. Yeah. So there are some mountains in our data landscape, and we know if we on top of a mountain, we see the world in a bit of a different way. And querying your data, you get new insights. You will get this experience of, yes, I've made it, found something interesting, that's beautiful. And that's also then the fun part in the analysis. Coding sometimes gets a bit tedious and boring after a while. But look forward to the analysis part. It's going to become interesting again. That's also then when you start how things are related. That's when you more frequently move to use the network view function. So you can start with kind of simple relations of things. They may get more complex over time. Colors can be used quite nicely here again to show also patterns in your data. It's easy to see from which categories and groups these codes are coming. And this is an example out of a PhD thesis, actually, from Eddie Hartman. Then he developed types, and you see here that you have the almost yellow and a bit of orange type, and this type is the red, yellow, orange type, and so on. And then often there are different subcodes that describe a certain type. So this is a nice way of actually also visualizing your findings. And what you see here are the ways, the arguments, these are quotation and their IDs, that leads up to this particular type, or that explains the type. So these are some examples for visualization and bringing it all together. And I promised, or I told you that, well, there's also a story here in our data landscape, or in the data landscape I've used here throughout the presentation. And the interpretation could be as follows. Previous explorers found out which people belong together, who is living where and related to whom, and furthermore the secret attraction of this value, the cairn of wisdom, that you can see here. Not everybody has access to the cairn of wisdom. Some can only observe from the outside, while others undergo various rituals in order to gain entry. However, this requires such mental strength and willpower that not all inhabitants of the valley or its visitors will succeed. If you enjoy storytelling, look at the concept map laid over the data landscape and try to continue the story. You can embellish it with further detail, mystery, and possibly a happy ending. Yeah. So this is a bit of the story about this data landscape that you can see here. Not some people that did go the dangerous way through the swamp in real life, not encoding the data, or took the power walk. They can enter here. The others don't have the strength. They have to watch from the outside. And so you're all a bit of storytellers. So use the network view function to tell the story of your data, to bring it all together, to pinpoint the most important aspects of your research and what you found. And to bring it all together, this is the process of computer-assisted NCT analysis. So I divided in a descriptive level part and a conceptual level part. The descriptive level part has to do with coding and building your coding system. I divided in the first stage coding and second stage coding. So first stage coding is about exploring, reading your data, noticing and collecting things, having lots of ideas, the bubbling thoughts and the sparkling ideas. And once you have done that, once you have a list of probably 100, 120 codes, you have them easily, you start sorting and structuring them. That's all the second stage coding. Yeah? So that entails Saldana's first cycle coding. So the first stage is to develop your coding system up to a certain extent where you at least have some structure into it. And then you apply this list in second stage coding to the remaining data material or to new incoming material, depending on your approach that you're using, or your methodology, overall methodology that you're using. So second stage coding means applying the structured code list to the remaining data, and of course doing a bit more resorting and refining of your code list still. So we do have this process of noticing, collecting and thinking, and first stage coding, and also in refining, building subcategories, or aggregating descriptive codes to conceptual codes. We do have this process again here when we further continue in noticing, collecting, thinking. So it actually accompanies us the entire way, also during the conceptual level phase. Conceptual level phase means using tools like the memo function, all the analysis tools, and the network view function. So you start querying your data, you start writing memos. Yeah, we go to this side, you see here the research question memos that start become to be more important at this stage. And once we see how things are related, then we start building networks and to start visualizing our findings. If you turn to the left side of this this image, then we see that you start writing memos from the very beginning with your research diary, with your first theory memos in terms of theoretical aspect or aspects from literature. You have idea memos, team memos, code memos, and so on. My advice was to set up some of these memos from the very beginning, so you start collecting your ideas. Don't write a single idea for, or don't write a memo for each single idea. You also write comments throughout, but think about comments. These are short sentences, and you write them directly with the object, mostly directly with quotations or code comments. These are the definitions, or comments on your primary documents. And this is all explained also in the book of giving some examples here. And so all of these together are then kind of not all of this finds the way in your report, but it builds up so you can put the bits and pieces together, mainly the research question memos, and then your network views to write your report. So this brings me to the end of this journey. I hope I've given you some ideas, also for teaching, for lecturing, and good luck and have fun.